Hi, welcome to the video tutorial for two lessons in the ratio strand. Lessons 25 and 28 both come under the umbrella title of triangle ratios. So you're going to think about ratios, but you're going to think about it in the context of triangles. In lesson 28 you end up getting the children to draw a sine wave. But that is not the aim of the lesson. The aim is to see the patterns in the ratio, where you compare the two numbers. So you could use it in introductory to trigonometry and trig graphs, but you could use it to get them to think about ratio, and that within a triangle, all the rules are just special cases of the ratios. So I think you have to choose and think, how do you want to do this? I've had schools where people have done this in Key Stage 4 to teach the content. I've had schools that have done this in Year 8 where they're just exploring patterns. And hey, look what we've got. Oh, it's a wave. And I happened to teach one of these lessons earlier on this week, and what I found was a sheet to try and promote the children to reflect and to share their ideas in a way that comes from the umbrella of metacognition, which is a strong feature of this project, which is there were stems for talking. I'm thinking, I'm wondering, this is like, I'm picturing, this reminds me of, I'm figuring out, I've just learned. It was the I'm picturing that resonates strongly with many children, because they started to picture the pattern and what was going on. So again, choose how you do these lessons. You could do lesson 25 as a short version, introduction to lesson 28, or you could do both of them, one after the other, or a week apart. It's up to you. Or you could spend a week doing both lessons, if you really wanted to push a group to focus on trigonometry and patterns and where it all comes from. I had that exactly same situation with both my two daughters. One of them, the eldest, hadn't really done the trig graphs and didn't understand the pattern, so I had to help her when she had a question, a non-calculated question. I did this activity with her. The youngest had a different maths teacher and said, "Oh, Dad, we did those patterns in Year 10. So again, I think it's worth discussing, what are we exposing the pupils to? Are we exposing them all to challenging mathematics in a way that's not as threatening as some challenging activities could be? So you could do lesson 25 as a bit of an investigation where you give them all different bits of it. Read the notes, because it goes into a lot of detail there, how to structure the learning. Essentially, you give the class something to do, they share the results and they spot the patterns. So it's a good time to also recap the names of the parts of the triangle. Like, this is the angle, that's the right angle, this is the adjacent, that's the opposite, that's the hypotenuse. And you say, okay, what you essentially get them to do is you get them to draw different triangles at different degrees. Measure the adjacent, measure the opposite, measure the hypotenuse, and just see what they notice. Any patterns that they notice. So one way of starting this lesson could be to give each pair a piece of paper so you give them the angle of 30 degrees, but you give them a different length adjacent. And they don't know this. So you could say 5, 10, 15, 20, 25, but they've actually all got 30 degrees. 30, whatever. Just to get them to explore patterns, and then actually, what's more important is the angle. The sizes follow the angle. So, and they can see relationships as you increase this is increased by a certain amount, this is increased by a certain amount, to see what's going on inside the triangle. The second part of the lesson is you actually start exploring triangle ratios and relationships. So if they know this, you could say, well, what ratios could we explore? We could explore the opposite over the adjacent. We could explore the opposite over the hypotenuse. We could explore the opposite, or we could explore the adjacent over the hypotenuse. You can say these are ratios, and you can explore the difference between ratios and fractions, similarity between ratios and fractions, and get them to actually explore individual ratios. So here we're going to explore the tangent ratio, and they're given different angles. Again, it's better if the class do this together and pool their results. So some people have to draw an angle of 10, an adjacent of 5, 10, 20, to notice that actually the ratio stays the same. And what's happening to the ratio, and why might that be the case, by visualising, if we're increasing the opposite, what's happening to the adjacent. Then you could do that for the sine ratio. what the pupils actually do is they end up with a table where they're comparing the tangent ratio with the sine ratio. Again, what do you notice? What patterns are there? You could then move on to doing this. Give them the angle, 15, what do you notice? Can you work it out? How do you work it out? What if, and the questions will come to you as you do this with the pupils, but the focus here is on what do you notice, what patterns are there. Again, I often don't do these lessons justice, I'm just sharing how I view the lesson. So read the notes and decide how you want to do it. I like to focus on how I manage the learning, not necessarily what the outcome will be, because you don't know about spotting patterns. Things will come up in the lesson that you would then want to address later when you do some specific teaching and some specific instruction. So lesson 25 is just exploring ratios and triangles, focusing on the tangent and the sine because the ratios are so different. What happens in lesson 28, you actually get them to imagine what's happening to the ratio as you change the angle. So if you've done lesson 25, there's less preparation to be done. If you haven't done lesson 25, you need to prepare the children with a clock like this, a big circle and two parts of a triangle. So you need to explain that if I put that in the middle of the circle, I can make a triangle with the hypotenuse and the opposite that moves around. Okay? So they can see that here, well actually it's better at the end if you put the axes on and you tell them that this is 10. So, you can then say to them, oh, let's do it at about an angle of 30. This is 10. How big do you think this is? This triangle that stops at 0. Oh, it's about half. It's about 5. So we know from the previous lesson that the sine of 30 is a half, because it's 5 divided by 10 is a half, the opposite over the adjacent. So what the pupils do, there is a worksheet, what the pupils do is they get a circle, 0, 90, and the angles are marked down. And what they do is they draw a little triangle. That's 10, and then they count up what that is. For 10 to about, and what they do is they do lots of sums where they're doing the opposite of the hypotenuse, which is always divided by 10. Up to 10, it's 1.7, so the answer is 0.17. And they have to then, and you can either use, I would always give them this circle to fill in, but often I don't give them the worksheet. When I taught it this week, one group I did, the other group I didn't. We just wrote the results on the board as they worked them out. They just worked out the values from 0 to 90 to see what was happening. And what I did with this particular group was, we had, the angle was 0 to 90, and so on. And what we did is we filled some of these in. Some of them had worked out the one for 90 was 1, this was 0, this was 0.17, this was 0.5, this was 0.64 or whatever. And they had to try and describe the pattern. And they were saying things like, it's always going up in 0.17s. Oh no, it's not. It's going up more and then less. The difference is more, the difference is less. I say, okay, what do you think that looks like if we plotted it on a graph? So then you got the idea that you have, well, is it like that to 90, or is it curved? And that was a really rich discussion because they had to try, one boy describe this curve perfectly by changing the difference between the numbers. But I said to them, how are you going to visualise what he's drawn? What does it look like? Is it a straight? Oh, it's not a straight line. Oh, it's a curve. So we got to a point in the lesson where they had drawn this, and that's 90 degrees. And I said, okay, and that's 1. Okay, draw the rest. What do you think it looks like? And they had their little, they had my big circle, they had their circle that they could draw. And what's lovely is they start to see the symmetry. And the fact that it looks like a really big, really really strange spider that has more than 8 legs. And they see that, oh, that's the same. Oh, it goes back down the same. And obviously then they can plot this. And the question is, what next? What happens next? And what is lovely is these children will share that there are three options to what happens next. I'll just do it at the bottom of this one. So you've got 1 here, you've got -1 here. That's 180. What happens next? Some think it does that. Some think it does that. Some think it does that. And you've got to let them say why and reason and explain. And what starts to happen is they all start to realise that it does that. And in this lesson, there's a girl called Amber that said, "Oh, it's like a wave." She said, "I'm picturing a wave." So what should we call this wave? Is it? And someone said, "Oh, it's from the ratio." So I said, "Oh, we can call it a ratio wave." And I said, "Do you know what that ratio is where you have the opposite over the hypotenuse?" I mean, I hadn't done 25 before, so I hadn't introduced the term sine, cosine, whatever. So I said, well, actually, that ratio is called sine. So we could call it a sine ratio wave. Then you've got to decide where you want to go. There's an option of drawing cosine and tangent curves as well. But what I did say to them was, well, could this carry on going in our minds? Could we keep going around the circle? Oh yeah, it can carry on going. So I said, okay, what's the sine of 400? Or the sine of 390? And some child said, well, it's the same as that. So if it's 390, it's 50. It's 0.5. Eh? No. And they start to spot the similarities and the patterns. Now I think it's up to you to decide how you want to use this lesson. Try it in lots of different ways. You could use it with older pupils just to actually sort of see where the patterns come from. You could use it as an introduction in your looking at ratio, but it really, the two lessons work very well together, and we had a really enjoyable time looking at sine waves with the two particular year 8 groups this week.